Hello guys, good evening. Welcome to the today online class. I am Dr. Suresh Babu, Professor, Department of Civil Engineering. Okay, see, as you know that from the last class, we came to know that how to determine DWF and WWF. What is DWF? Dry weather flow. And WWF means wet weather flow. Wet weather flow means what actually? It is a storm sewage. Storm water can be determined by using this rational formula method. What is very simple formula? It is AIR divided by 360. See, this is considered as Q2. Okay, Q1 is DWF. Dry weather flow means it is purely sewage, so that it is coming from the society, that is population into rate of water supply into what actually percentage of sewage. We came to know after determination of Q1 and Q2, the ratio can be easily determined. All the problems ratio only. Okay. Now by adding these two, it will be combined sewerage flow. If you provide two separate, then it is called separate sewerage system, and this is combined sewerage system. Then this is partially separate. This is a fundamental. Based on this only, you can go on changing the types of problems. Now in the last class, we came to know that whenever the factors AIR are unknown, whenever the factors AIR unknown, see, whenever the factors are AIR unknown, then it is somewhat you have to think. Okay, because everything is known, given value, then substituting this equation in, that is the values into this equation, is very easy. But whenever the problem arises, the factors are not known, then you have to determine how to determine. That is very, very important. One is A, another is I, another one is R. If you know these three parameters, everything becomes very easy. But in the last class, A is what, and then I is what, and what are the standard values of I. Okay, these are the standard values of I we are going to use for your problems. Okay, watertight roofs, pavement of asphalt, okay, pavement of asphalt, and then bricks or macadam road, or what you call areas are many buildings, and then few buildings, see lawns, forest, etc. So based on the type of roof, type of surface, we have to take these standard values. The standard values usually we will consider in this bracket. Try to understand. See, when the runoff is more, this value is also more. It is understood that, because then that is actually waterproof area. Because the water infiltration is less, then runoff is more always. It is a common sense. Now, this I value will varies with respect to the area. Now, this I will be changing with respect to surface size of the land area. Remember it. It is surface and size of the land area. Okay, agree? Right. Now, let us start with this one. See, A can be determined by means of map. Okay, I can be determined using this equation. What is sigma AI divided by I? What is AI? Sigma AI, summation of all the areas, and with respect to that area, I value you have to multiply. Okay, AI is equal to sigma AI is equal to A1 I1 plus A2 I2 I3 A3 I3 etc. Okay, where A1 A2 is nothing but what you call the areas of different surfaces. Okay, in terms of hectares. Then I1, I2, I3, etc. is corresponding impermeability factor for different surfaces. Okay, try to understand neatly and able to solve very easily. See, 10 marks question is a compulsory question. Remember it. This problem will arises in your question paper 100% guarantee. That is why I am stressing many times how to solve this problem. Okay, A is the total catchment area. That is, if you add all those things, you will get this A. See, this I will be knowing that this is a constant. Okay. Next is rainfall intensity. How to determine this R? AIR. I is over, A, that is A is over, I is over, and R. R can be determined using this formula. Okay. This general formula is this one, and what is A, what is B, both are constant, and what are those values, everything we know that. This is A, this is B, and this is A, and this is B, and what is the T. Okay, see here the different equations are given, totally 4 equations. Okay, those 4 equations, you can see that this is a fourth one. Now, along with this, a problem was solved using those parameters. How to determine the find out? No, see, observe ಮಾಡಿ ಇಲ್ಲಿ ನೋಡ್ಕೊಳ್ಳಿ. Find out the dry and wet weather flow rates and their ratio. This is a problem 100% going to as same style. Okay. Now, today what we are going to do is we have to start with another type of problem which is showing some standard values. These are the values. These type of things, different area they will give, and you have to find out that area, what is the amount of area, and then what is the value of I. Okay, let us start with that type of problem. Yes, today we are going to start with a new type of problem, that is in the design of sewerage system. Sewerage means 3 types of sewerages are there. Which one is suitable for your problem, you have to determine, right? Here a new type of problem, that is different type of surfaces they are given, and percentage of total area, that is percentage of area also how much they are given with respect to what you call this surface. If for example this is actually what you call watertight roofs, and this is a 30%, and then runoff coefficient is how much it is. See, like 1 minute. See, let us start with this problem, and then you can be able to understand what is clearly. This is a third type of problem. Understood? This is third type of problem. What they are giving. Usually observe here. Dry weather flow and wet weather flow you have to determine. Then what are the data required? Population into rate of water supply. Population into rate of water supply. And then percentage of sewage. If suppose not given, you assume that percentage of sewage and solve the problem. Don't leave any kind of this problem. Problems are so easy. That is why I am stressing many times to solve this problem. Okay, now let us start with this problem. See, a city is having a population of 20 lakhs. Okay, a city which is having a population of 20 lakhs on, see, observe, and an area of 20,000 hectares. See, city is having population this much, and the catchment area, an area of 20,000 what you call hectares, receives and water supply at a rate of 180 LPCD. Okay, 80% of which flows out as spent water. See, spent means ಖರ್ಚು ಮಾಡಿರೋದು ಅಂದ್ರೆ ಏನು? Spent, it is utilized. See, now 80% of water is flows out as a spent water. Okay, now the total area of the city, ಅವನೇನು ಮಾಡಿದ್ದಾನೆ, ಟೋಟಲ್ ಏರಿಯಾ ಕೊಟ್ಬಿಟ್ಟಿದ್ದಾನೆ 20,000 ಎಕರೆ ಅಂತೇಳಿ. ದೇ ಆರ್ ಗಿವನ್, ಬಟ್ ದೇ ಆರ್ ಗಿವನ್ ಇನ್ ಡಿಫ್ರೆಂಟ್ ಫಾರಮ್. ಸಿ, ಇಫ್ ಯು ಆ್ಯಡ್ ಆಲ್ ದೋಸ್ ಥಿಂಗ್ಸ್ ಯು ವಿಲ್ ಗೆಟ್ the same percentage of area. Okay, now let us see that one by one. So now in this case, see, nature of the surfaces, totally 5 surfaces they are given. Percentage of total area, see, 30 means what? 30% of what you call 20,000 hectares. See, this watertight, what you call watertight roofs are waterproof. Okay, this is watertight roofs, number 1. Okay, this will be how much it is, how much area it is. See, in world, any world, it is having this one. Watertight roofs are so many. Now percentage of total area, percentage, how much it is? 30% of the total area. How to read this? This is watertight roof 30. 30 means 30% of total area. That is the meaning. If you know this problem becomes very, very easy. Second one is hard pavements. This is 20% of the total area. And then unpaved means 15% of the total area. Lawns and gardens 25% of the what you call total area. And then finally wooded. Yeah, wooded means some trees are existing in that area. See, just like in a camp, okay, we can see the plenty of what you call trees. That is, in, for example, ವ್ಯಾಕ್ಸಿನ್ ಡಿಪೋ, ಅಲ್ಲೆಲ್ಲ ಸಿಕ್ಕಾಬಟ್ಟೆ ಮರಗಳಿದಾವಪ್ಪ, ಅಲ್ಲೂ ಪೈಪ್ಲೈನ್ ಬಂತು ಅಂತ ಇಟ್ಕೊಳ್ಳಿ, ಅವಾಗ ಇವನ್ನೆಲ್ಲ ಸಾಲ್ವ್ ಮಾಡಬೇಕಾಗ್ತದೆ. ಬಿಕಾಸ್ ಸಿವಿಲ್ ಇಂಜಿನಿಯರ್ಸ್ ಹ್ಯಾವ್ ಟು ಫೇಸ್ ಫಾರ್ ಸೋ ಮೆನಿ ಚಾಲೆಂಜಿಂಗ್ ಒನ್. ದಟ್ ಈಸ್ ವೈ ಐ ಆಮ್ ಶೋಯಿಂಗ್ ಆಲ್ ದೀಸ್ ಥಿಂಗ್ಸ್. See, anyhow, we are going to solve many types of problems now. Okay, see, now here this is 30, whatever 30%, this is 20%, this one. See, this we add all this percentage. You have to get 100%. Okay, compulsory you have to get 100. See, 30 plus 20 is 50. 50 is 60, 80, 90, 100. This is the total area. 100% of total area means how much it is? It is 20,000 hectares. Okay. Now, respective area having I values. These I values you have to remember. Okay. Now, next. See, he has given this value along with the table. This is the remarks. Keep it as it is. Next, determine the average coefficient of runoff. The data gathered in the city indicates time of concentration is equal to so much. How much it is? 0.3 hours. They are given. Now you have to see that how to solve this problem. Okay. Design the rainfall intensity using this R is equal to 1500 divided by T plus 32 mm per hour. The rainfall intensity can be determined using this formula. The formula he has given. Use it. That's all. Don't go for assumption. Next, the rate of infiltration. Again they are given rate of infiltration. Rate of infiltration means going inside the pipeline. It is how much? 9,000 liters per hectare per day. 9,000 liters per day per hectares. Okay. Find out DWF and WWF. ನೋಡಿ ಮತ್ತೆ ಅದೇ ಕೇಳ್ತಾ ಇದ್ದೇನೆ DWF and WWF with their ratio you have to find out. Okay. Also significant also suggest a suitable sewage, that is called suitable sewerage. Which type of pipeline is suitable, whether a combined flow separate flow system or partially separate, like that. Okay. See, here suggest a suitable sewerage system. Use rational formula method. Rational formula method he has given, and using that only you have to solve. Okay. And rational directly they are given. Use rational formula method. See, now let us start with this one. Solution. Solution means what? Population is equal to how much? Area is equal to how much? And what you call? Sewage is equal to 80% of the water supply. They are given. Rate of water supply how much? 180 LPCD. Okay. Then R is equal to this value. Now you have to solve one by one by using first case, second case, third case, like this. Okay. So now R is equal to 1500 divided by T plus 32. Okay. And where T is equal to, observe ಮಾಡಿ ಇಲ್ಲಿ T ಯಾವಾಗಲೂ ಏನು ಮಾಡ್ತೀರಿ ಎಲ್ಲ mm per hour ಇದೆ. ಅದೇ ಥರ Tನೂ ಅಷ್ಟೇ. T means time of concentration. See, they are given time of concentration. It is in minutes only. Time of concentration is minutes. But you observe here, they are given in terms of hours. They are given in terms of hours. Time of concentration is 0.3 hours. 0.3 into 60 minutes, how much is it? It is 180. That is 18 minutes. Okay. See, infiltration concentration is 0.3. Okay. In this problem, you have to determine DWF, WWF, and Q1 and Q2. That is, these two you have to determine, and then ratio also you have to find out. Okay. They are asking cleanly, that is neatly, find out DWF and WWF. Okay. With their ratio. They are given clearly about this. And also suggest a suitable sewerage system. Okay. Using rational formula method. See, everything he has given. Only you have to solve the problem. Right? Let us start with the problem. First case. Q1 is what actually? DWF. This is a dry weather flow. Here population into rate of water supply into percentage of sewage. Plus this, because we are adding Y means the infiltration. Water is coming inside the pipeline, that is a sewer line. So that water is going to increase. So that infiltration you have to add. How much they are given? 9,000 liters per day per hectare of area. You are getting this much. Okay. Now let us add with this one and then solve the problem first. Okay. What is population? What is the amount of population? They are given 20 lakhs. That is 20 into 10 to the power of 5 it is. into rate of water supply 180 LPCD. Okay. Next, the percentage of sewage is 0.8. See, you have to convert. Okay. This is LPCD. Liters means 1000. Because liter you have to converting into what you call metric cube. And then this is hours, liters per day. Day is in terms of seconds you have to convert. So day is 24 hours into 60, that is 3600. In the last class, before last class, we have solved that problem. Try to go through that one. Okay. Now this is 9000 LPCD. This is liters per day per hectares. Now how many hectares are there given? So the area is the total area is how much? Do you know? What is total area? Area is 20,000 hectares. See, 20,000 hectares, they are given very clearly. Now we have to solve the problem. Okay. Now that is for 1 hectares 9,000 liters. Then 20,000 means how much it is? You have to solve this problem, multiply with this, and then divided by, they are having what you call the conversion factor. Okay, again you have to convert in terms of metric cube per second, that is conversion. Next, substitute all the values in this equation. What we will get? That is a Q1. That is a 3.33 mm you got. 3.33 metric cube per second. This is actually the first equation. Now infiltration rate also you have to calculate. You will get 2.08. You add this plus this, you will get 5.41 metric cube per second you are observed. Again, the second case. The first case is we have to determine DWF. Second case is WWF. Okay, this is Q2. Now, in this case, you have to use, in the problem they are given, use a rational formula method. Now, here we know that the rational formula is AIR divided by 360. Area is known, 20,000 hectares already given. Don't know. R is rainfall intensity, that is also don't know. You have to determine those two factors. Okay, I and R. Now let us start with the equation. I is equal to sigma into sigma AI divided by capital letter A. See, now you have to determine using this I value. Okay. Now let us start with one by one. I will give only one. See, sigma means what? A1 I1 plus A2 I2 plus A3 etc. divided by capital letter A. I have given already this formula. You just go through how to solve, how to use this formula. Okay. What is A1? See, A1 is nothing but the area. See how much they are given in the problem. It is a 30%. I will show you one. Okay. This 30%. See that 30% into total area. That is 30% of the total area means 30 into 20,000. That is divided by 100. But this is a 0.3. It will become 30% means 0.3. Into 20,000, we will get how much? 6,000 value, A1 value. And then I1 value, I1 also known. Okay, we know I and then this is small A1. Okay, then like this similarly A2, I2, A3, I3, and then that is totally number of items are how many? See, up to that. This is a 5 items are there. See, you have to go and tell directly into this. Okay. Now, the values are, we are knowing that. Substitute all the values in the equation. Totally 5 equations are coming divided by, this is area. Area is 20,000. See, if you multiply with all these values, okay, and finally I is equal to, you will get a 0.5075. After I, again, what you got? See, A is over, I is over, and R you have to determine. Where is R? See, R is having a formula he has given in the problem. See, the design R value can be determined using this. Okay, T plus 32. See, now similarly, see, you have to use the same formula. See, that formula T plus 32. Now, you have to go for simplification. T is equal to how much? That is also there given. How much it is? 18 minutes. How you got this? See, 18 plus 32. Okay, how you got that calculation? You have to solve this. T plus 32 is the standard value. 32 you have to keep it as it is, and T value. T is nothing but hours. In terms of hours they are given. See, that is 0.3 hours. 0.3 into 60 minutes per hour. How much it is? 18. So that you have to substitute into this t value. Then divide by this much and then find out the final value. 1500 divided by 50. So that you will get a 30 mm per hour. This R is can be determined. R can be determined so easily. Okay. What is the unit of R? See, mm per hour. Next is WWF. See, in WWF, what is Q2? Say Q1 you are determined, Q2 we want. Okay, AIR divided by 360. Now all the parameters are known. Just you substitute those values. We'll get this answer. So okay, here infiltration, exfiltration ಬರೋದಿಲ್ಲ. ಅದು ಬರೋದು ಎಲ್ಲಿ ಡ್ರೈ ವೆದರ್ ಫ್ಲೋನಲ್ಲಿ ಅಷ್ಟೇ ಬರೋದು. You have to add for the Q1 value. Okay, this is now we know these values. Whenever you are getting value, try to put a box inside. Okay, the answer is 845.83 meter cube per second from this equation. Okay, next we have to go for ratio. This is the third case is ratio Q1 and Q2. See, if you do like this without doing any mistake, you can score full out of out. See, I am stressing many times to solve the problem. ಪ್ರಾಬ್ಲಮ್ ಮಾತ್ರ ಬಿಟ್ಟು ಬರಬಾರ್ದು. ಯಾವಾಗಲೂ ಏನಾದರೂ ಆಗಲಿ ಮಾಡಿ ಬರಬೇಕು. ಓಕೆ, ನಾವು ರೇಷಿಯೋ ಸಿ DWF ಡಿವೈಡ್ ಬೈ Q1 by Q2 ಆ್ಯಂಡ್ DWF WWF ಎಲ್ಲ ಏನು ಮಾಡ್ಬೇಕು ನೀವು ರೇಷಿಯೋ ಕಂಡುಹಿಡಿಬೇಕು ಅಂದರೆ ದಿಸ್ ಡಿವೈಡ್ ಬೈ ದಿಸ್. ಉಲ್ಟಾ ಮಾಡಿದರೆ ನಿಮಗೆ 1 by ಸಮಥಿಂಗ್ ಬರುತ್ತೆ. ದೆನ್ ಫೈನಲಿ ಇಟ್ ಈಸ್ ರೇಷಿಯೋ ಇಸ್ ಹೌ ಮಚ್ 1:156.35. 2 digits are more than enough. And then comments. Comment means now you observe that. So this is a storm water, this is sewage. These two are ಸಿಕ್ಕಾಪಟ್ಟೆ ಅಜಗಜ ಅಂತಾರಲ್ಲ. This is far away from the source. Now this is a huge amount. If you provide combined sewerage system, it is a difficult case. See how it is, because the sewage water along with the rain water gets polluted or contaminated. You have to write these comments on this. Okay, see that why we have to provide and what we have to provide, how we have to provide, everything is given in this. Okay, see guys, these are the problems, the 3 varieties of problems. I have solved all type of cases, okay, which are asking in the examination. Please try to solve yourself by looking into this same problem. Don't simply ಬಾಯ್ ಟುಡೇಗೆ ಹೋಗೋದಾಗಲಿ ಏನಾದ್ರು ಮಾಡೋಕ್ಕೋಬಾರ್ದು. ಇದು ಸಾಲ್ವ್ ಮಾಡಿದರೆ ಮಾತ್ರ ನಿಮ್ಮದು ಅಂತ ಬರ್ತದೆ, ಅದರ್ವೈಸ್ ಇಸ್ ನಾಟ್ ಕಮಿಂಗ್ ಫಾರ್ ಯು. ಓಕೆ, ನೌ ದೀಸ್ ಕಾಮೆಂಟ್ಸ್ ಆರ್ ವೆರಿ ಈಸಿ. ನೆಕ್ಸ್ಟ್ ದ ಟಾಪಿಕ್ ಈಸ್ ಟೈಮ್ ಆಫ್ ಕಾನ್ಸಂಟ್ರೇಷನ್. ವಾಟ್ ಈಸ್ ಟೈಮ್ ಆಫ್ ಕಾನ್ಸಂಟ್ರೇಷನ್? T is equal to TE plus TF. Otherwise T is equal to T1 plus T2. You can determine this value. What is our title? It is time of concentration. See, time of concentration we are clearly explained here very neatly. Time of concentration means concentration is the rainwater. Due to rainwater, it falls on the ground, and finally what happens? It starts moving. See, this is what you call. See, it will moving towards a drainage. That is a sewer. Okay. See, observe here how to define this. The term is used to design storm water drains. Okay, time of concentration is used to design storm water drains. Okay, as the rainfall on the ground, all the area to be served by the sewer does not start to contribute immediately to the flow of sewage. You observe very carefully. See, this one is the time of concentration. Concentration, rainfall. Rainfall, how long it has been occurred. That is the only one. Okay. See, to build up the rainwater, that is a storm sewage, storm water entering into the pipeline, how much you have to determine. See, it will be mainly based on these 3 factors. Okay. The area just ನೋಡಿ ಸ್ವಲ್ಪ ಅರ್ಥ ಮಾಡ್ಕೊಳ್ಳಿ. ದ ಏರಿಯಾ ಜಸ್ಟ್ ನಿಯರ್ ದಿ ಸೀವರ್ ಲೈನ್ ವಿಲ್ ಸ್ಟಾರ್ಟ್ಸ್ ಕಾಂಟ್ರಿಬ್ಯೂಟಿಂಗ್ ಫಸ್ಟ್. ಹತ್ತಿರ ಇರೋದು ಫಸ್ಟು ಅದಕ್ಕೆ ಕಾಂಟ್ರಿಬ್ಯೂಷನ್ ಸ್ಟಾರ್ಟ್ ಆಗಿಬಿಡುತ್ತೆ. ಮಳೆ ಬಂದಾಗ ಸ್ಟಾರ್ಟ್ ಆಗುತ್ತಲ್ಲಪ್ಪ ರನ್ ಆಫು, ಆ ರನ್ ಆಫಿಂದನೇ ನಮಗೆ ಏನಾಗ್ತದೆ, ಯೂಸ್ ಅಮೌಂಟ್ ಆಫ್ ಸ್ಟಾರ್ ಅಮೌಂಟ್ ಸಿಗ್ತದೆ. ಆ್ಯಂಡ್ ಇಟ್ ವಿಲ್ ಗಾನ್ ಇನ್ಕ್ರೀಸಿಂಗ್ ಆ್ಯಸ್ just ಓದ್ರಿ ಇದನ್ನು. See, goes on increasing as more and more area starts contribute. ನೋಡಿ, ಫಸ್ಟ್ ಒಂದೊಂದೇ ಜಾಯ್ನ್ ಆಗಿ ಕೊನೆಗೆ ಏನಾಗುತ್ತೆ, ಸ್ಟಡಿ ಆ್ಯಂಡ್ ಯೂನಿಫಾರ್ಮ್ ಫ್ಲೋ ಆಫ್ ವಾಟರ್ ವಿಲ್ ಗೆಟ್. ದ ಸೆಕೆಂಡ್ ಪಾಯಿಂಟ್ ಈಸ್ when the whole area is contributing to the flow of sewer, the maximum limit of flow will be reached, okay, and it will be able to reach, okay, and it will be equal to the rate of precipitation of rainwater. And finally this one, the maximum flow, what we call, continuous until the storm stops. Try to understand what is time of concentration. This is a rainfall. See, it consists of two parts. One is the time of entry and then time of flow. In the last class I was explained very neatly what is time of entry and what is time of flow. The time taken to reach the uppermost sewer line is called what you call time of entry. Up to entry, suppose you are going to a movie, you are planned to go to movie, then what to do? See, you are going to dressing and etc., you are preparing for that. Then you will start your journey from your house. From your house, how much time will be take to reach that theater? That is called time of what actually? Entry time it is. Next, after sitting there 3 hours movie, then it is a flow. See, like this, T1 and T2 you have to add, you to get a what you call total time of concentration. Okay, now you observe here the total time required by the flow to reach to the maximum limit. See, the total time required to flow to reach to the maximum limit is known as time of concentration, and it consists of two parts again. Okay, see, let us see that what are those two parts. Time of entry, that is called entry time, and then time of flow, that is called flow time. You have to remember this. Based on this, you have to solve one more problem on time of concentration. Suppose they are given in the problem, just to add this t value. See, it is very simple. Many people won't solve this type of problems. Okay, this is the time of entry. See, what is this time of entry? We are given very beautifully the definition, and time of flow also I have given the beautiful definition of this. Okay, this is the time of flow is equal to distance to be traveled and divided by velocity of flow. If you know velocity, what is the meaning of velocity? Tell me. What is the meaning of velocity? What is the unit of velocity? Meter per second. That means distance traveled with respect to time. Now, T is the concentration. V is the what you call? V is the m per second. It is a milligraph. And then L by T. See, L by T means what actually? Already basically we know that the velocity V is equal to L into T. See, the same equation we are classified. That is classified into like this. Okay. One is the distance traversed, another one is velocity of flow. See, now V is equal to L by T. So this is one type of problem. Okay. In addition to the time of entry and the time of flow, it gives a time of concentration. What is this? This addition of T1 plus T2 is equal to T. That is the total time of concentration. See, finally, the quantity of sewage is equal to area of sewer. See, the area of sewer into velocity of sewer. This is area and this velocity into what you got? Velocity means what? And if you know these values, directly you can substitute here. You will get the answer. So, Q is equal to AV. See, here, as in today, we have learnt a lot of things. The problems, how to solve the problems. See, varieties of problems will be given in the examination. Okay. First method is a plain method. So, you have to determine Q1 and Q2 and find out the value. Second method is what actually, when the proper, what you call AIR is unknown. Using rational formula method, only you are going to solve. When AIR is unknown, then you have to determine the value and then directly you substitute into that equation. AIR divided by 360. Finally, you will get the answer. See here also, in this today, you have solved the problem and then time of concentration as per your syllabus. Okay, just to go through that syllabus, you will get all the things. Okay, today I am going to stop this. Okay, thank you one and all. Try to repeat continuously, otherwise it is very dangerous subject. Here onwards, try to contact and try to be regular to the class without fail. Okay, thank you one and all. Wish you best of luck.